Hello everyone, welcome to my channel Essentials of Electronics. In today's video, we're going to discuss about the third type of power amplifier, the Class C power amplifier. In our earlier video, we have seen that the Class C power amplifier shows an output signal of less than 180 degree, isn't it? So how do we get an output signal less than 180 degree? That we'll get to know from the output curve. Yes, what curve is that? That is the output characteristic curve which is drawn between VCE and IC. So when a load line is drawn like this with the Q point is achieved here because of the list. Yes. So how do we get this? So for a period of 0 to omega t, when a particular input signal is fed in like this, the output signal is obtained for a very small duration of less than 180 degree. Yes, so this is IC, and this is the reason why the output flows, because the stability point goes lower, and for even more lesser stability points the output signal goes even less than 180 degree. Tuned amplifiers, yes, these Class C power amplifiers are also called tuned amplifiers, in which the tuning circuit is connected to the collector terminal of the amplifier. These amplifiers are employed for the purpose of tuning. Yes, tuning means we know generally selecting the variable frequencies. Yes, that is, the tank circuit will have an inductor, a capacitor circuit like this with L and C components. How does it relate to frequency? We know 2 pi FL is equal to 1 by 2 pi FC, this being the inductive reactance and this being capacitive reactance at resonance. So the circuit, this tuned amplifier circuit, will be operating at resonance condition. At resonance, XL is equal to XC, and therefore the resonating frequency FR is equal to 1 by 2 pi root of LC. So this LC circuit is called the resonance circuit. This part of the circuit is connected to the collector terminal of the amplifier. So here in this type of Class C power amplifier, we have three categories of tuned amplification. One is single tuned, the other one is double tuned, third one is stagger tuned. Yes, so based on the tuning circuit, yes, based on the resonance circuit that we are connecting to the collector terminal of the amplifier, they show their own behavior of bandwidths, and depending on that, these kind of circuits are used in radio frequency. These kind of amplifiers are used in are called radio amplifiers, or also radio frequency circuits. Yes, so I'll first draw the circuit diagram of a single tuned circuit. As I said already, it's a basic amplifier circuit with the voltage biasing. So we are used to draw this kind of circuit, isn't it? RE, CE, and here the collector terminal and LC circuit is connected to the collector terminal of LC circuit is connected to the collector terminal of the amplifier provided with R1, R2 resistors. So this is the source voltage Vin, coupling capacitor. This part of the circuit is a resonance circuit. R1 and R2 are the voltage divided by a circuit. The base and the emitter. Here, when the input signal is given, the amplifier amplifies through the resonance circuit and the amplitude of the output signal is obtained here. When we try to draw the bandwidth of this here with frequency or omega and bandwidth gain in terms of decibel for a small range of frequency, we'll be getting a curve like this for a very narrow path. And 3 decibel, reduce 3 decibel from the maximum peak. This is at resonance. At resonance, what is the condition? XL is equal to XC. So here we have F1 and F2. So the bandwidth of the single tuned circuit will be F2 minus F1. This is a circuit diagram of single tuned and its respective frequency response curve. Yes. Next we'll move on to the second type of circuit, double tuned. So do you have any idea of what is double tuned circuit? I'm just making a small modification here in the output of the transformer connected here. Earlier we had the output signal just directly getting from the secondary of the transformer connected here, but here we are having L1, L2, C1, C2 capacitors, and from that we are trying to calculate the output signal. So here earlier we had a single tuning circuit, here we have double tuned circuit, and hence the name double tuned amplifier circuit. And for this kind of response, this is the bandwidth. These are the various bandwidths that we are obtaining, and the earlier one remains the same. This is for critical coupling. This is, since we have two tuned circuits coupled together, we have different types of coupling happens here, and that is shown in the bandwidth graph. The earlier one is similar to the critical coupling. This curve is overcoupling, and this curve is called undercoupled curve. So this is the bandwidth of a double tuned class C power amplifier circuit. Yes. And now we'll move on to the third type of circuit. Yes. Again, I'm going to modify. The third type of circuit is called stagger tuned amplifier circuit. It is nothing but connecting two single tuned amplifier circuits together. Yes, I'm now going to draw the stagger tuned class C power amplifier circuit. Yes, the collector terminal is taken, connected to by a coupling capacitor, and it is fed to the base of another setup of a single tuned amplifier circuit with RE2, CE2, Q2 transistor. This again has a separate tuned circuit with the variable capacitor. This is going to be C2, L2, and we still have a separate R3 and R4 voltage divider biasing, all commonly connected to plus VCC. So here from this we understand that this first portion is a single tuned circuit and the second portion is again a single tune, but it is coupled together to form a class C amplifier called the stagger tuned amplifier. Yes, the output of the first amplifier is taken and coupled to the base of the next stage of single tuned amplifier, thus called a stagger tuned amplifier. We'll just look on the bandwidth obtained from this. This is the bandwidth in terms of radio frequencies, isn't it? Radio hertz, 300 to 30 megahertz. So this is in bandwidth, decibel. We'll be getting a frequency like this with unity gain, and at 0.707 decibels we'll be getting a curve like this, and also this would have been formed from the lower one. And yes, so these type of class C power amplifiers are having very high efficiency. They are excellent in operating in radio frequency applications, RF applications. They have the lowest physical size for a given power amplifier, and we have certain drawbacks of this. Yes, the drawbacks are it has a very low linearity. It is not suitable in audio applications. It creates a lot of radio frequency interference, and it was also difficult to obtain ideal conductors and ideal capacitors. Because of this reason, it has a reduced dynamic response. So we can use these kind of tuned amplifiers in RF oscillators, RF amplifiers, FM transmitters, booster amplifiers, high frequency repeaters, and hence the name tuned amplifiers. Yes, so in this video we have discussed about a class C type of tuned amplifier circuit. We have three types of tuned amplifier: single tuned amplifier, double tuned amplifier, and stagger tuned amplifier circuits. Thank you.